Welcome to the Langos Lab, which is actually my garage, as you can see. We can't have basements here in Virginia Beach because we're about 12 feet above sea level. But anyway, I want to do some demonstrations for you about early radios. So we have two exhibits we're going to look at. One is a Tesla Coil that I built a couple years ago, when I was in high school. Something like that. It doesn't work anymore. We'll talk about it in a second. And then I bought another one recently so we can do some demonstrations. 120 volts coming into this does exist, and I'll show you that in a minute. And it did work for a very long time. I'm just not sure why it doesn't work anymore. It's either the intake transformer or the capacitor. I'm just not sure. It just hasn't been turned on for a very long time. As we talked about earlier, we're going to do some math. So if you want to participate in the math when we get back to my office, you're going to have to take down some measurements. Not all the measurements I give you are actually going to be needed. That's okay. But every time I say a number, you probably should write it down because you're going to probably need it if you want to participate. So let's start. So the gap here between the inner coil and the outer coil is the first thing we need to measure. And it's about, let's say 2 inches. It's about 2 inches. So maybe a little bit more, but 2 inches is probably about right. We have to measure, and again, we're doing inductance right now in Henry's. So we need to measure the inductance, which is about, this is about 15 inches if I could put this all the way down in there. We're going to take this apart in a second. But it's about 15 inches. So that's an important measurement. Okay? The radius of the outer coil. Okay, this is important. Now I can take this off. And then I'm going to prove to you that there's electricity coming in here. So let's look at this. Let's call it 8 inches. So we'll call the radius, 4, let's call it 4 inches, okay? This is gonna help us do all the calculations upstairs. I'm gonna plug this in. And we have 120 volts coming in. You can see that, okay? And you can see it's about 10 amps coming in, all right? So that is the input to this step-up transformer, which is important because that's how you get the voltage that you need to show you what I'm going to show on this Tesla coil. So the input is that. The output in amps is about 0.3. Because conservation of energy, right? So you have to, the amount of energy that comes in has to equal the amount of energy. So a lot of voltage coming in and almost 0 amps coming out, which is important because that's the way the Tesla coil works. As you also can see here real quickly, which is I cut off part of my drumstick back when I was in high school when I built this. And it just helps grab a little bit more voltage before it goes into the coil itself. So this is a step-up transformer. As I said, you've got AC input right here, and you got an AC input here. So it starts by going through a capacitor, which is underneath here, which I will now show you. It's red. You can see it. It's a 100 picofarad capacitor, 100 picofarads. And it goes into the input of this larger coil, where these two go through what's called the spark gap, which is over here. And it's about 1/2 inch. And think about that as like when you used to tune your radio using the tuner, and it was to grab the resonant frequency. This changes the resonant frequency, and then this one is manual, and the other one it's also manual, but I can change it to be whatever I want it to be, and it changes the resonant frequency between this coil, the outer coil, and the capacitor resonating to produce electromagnetic energy that goes out into in wireless energy like radios do. This is a radio. I mean, it's a radio system, and we're going to calculate that upstairs. So it's a pretty basic configuration, but that's the way it works. And yeah, it seems like a lot of voltage, and it is, but it doesn't hurt you. And I'm going to show you that in just a minute. And we're going to do a few demonstrations, okay? So we're going to turn the lights off, and I'm going to start doing a few demonstrations on this coil, which actually works, but it's obviously, much smaller. So you have all the calculations you're going to need for when we get upstairs. Let's turn off the lights, and let's go through this. Very similar to what I showed you on mine. Let's start with one. This is called the skin effect. So I'm actually feeling it. It doesn't hurt. It's the way that electricity bounces off of objects and tends to stay on the outside of objects. So let's say you're in an electrical storm and you're in your car. The best thing is to stay in your car because it's going to stay on the outside. It's not going to actually go through you. Let's also look at now the radius. So let's look at the distance about how far the electricity actually goes. So obviously I have a fluorescent lamp. This isn't 100% accurate, but you can see, it's probably about 2 or 3 feet. The one that I created is more about 10 feet. Because it's a little bit bigger, but you can see that it's resonating electromagnetic energy pretty far for this. So it could, if it was in the realm of an AM radio or something, it could block it. So we're going to look at something else real quick, a couple other things. Do you remember in high school, or maybe college, learning the 4 states of matter? Solid, liquid, gas, and plasma. So this creates a plasma as well, which is high frequency electrons that are excited. This is basically what a radio wave does. This is just a visual representation of it because it's way lower frequency. And that's the 4th stage of matter. But what's also interesting about this is if you look at when I do this, right? This is called bremsstrahlung. Bremsstrahlung is when electrons hit a barrier and cause them to get more excited. This is the basis of how X-rays work. And the Tesla coil was it was used as an X-ray device and gave scientists, way more information about how to build, modern X-rays today. And again, it doesn't really come out because it just hits the surface. So I hope you got all the calculations down. And at this point, why don't we just go back upstairs to the lounge. This is now the studio lounge, the Langos lounge, where we have instruments and stuff. And we will do some calculations on what we learned today.